my BW system I've logged in, yeah. Pretty much normal, yeah. But if you go to systems and say what status, you start getting to see this. Says database system is what HDB, and what is my server name, host name? My database server name is what SAP Cubix, and this is the system ID SP9, and 01 is the instance which we are using. Actually, for me, in one server, in one host, SAP Cubix, I've got two instances. One is 0001. 00 is actually SP8, and 01 is SP9. Actually, so I made this BW sit on 01 instance, not on the 00. So it is getting connected to HANA database is fine, but which server it is? SAP Cubix and SP9, and what is this? 01 instance. And then there's something called owner. What is this? SAP ABAP 1 means what? HANA is a database, and all the database artifacts in HANA are organized with schema, are always qualified with the schema. So when I have my BW, when I make my BW to sit on HANA, all my database objects of BW like fact tables, dimension tables, active table, PSC, all your database dictionary of BW should go into some schema. Now, which schema is it? That is what it is. SAP ABAP 1. If I go back to the HANA system, we never used to log into the backend, but if I can still connect to the HANA backend, then if I go to Kettler, I should see I see a schema called SAP ABAP 1. If I go to, I can expand, it will take a lot of time, but when I expand the tables, you get to see all the tables of BW. Whatever you could see in SC level, you will see same number of tables here also. All SC level, we should see the table definition, which is actually showing from the backend database. In turn, I can even log into the backend database and see those tables also. And this is what tells you the schema name. We can refer this as BW schema. This is a schema where all your BW objects are placed into HANA data. You would BW HANA will కూర్చోబెట్టినప్పుడు BW సంబంధించిన టేబుల్స్ అన్ని HANAలోనే ఉండాలి. HANAలో ఉండాలన్నప్పుడు ఒక స్కీమాలో కూర్చోవాలి. ఆ స్కీమానే this is what the owner is. So with this I know in this schema it is going to make it to sit all my BW relevant objects. Okay, adogate. One more very very important point. When you have a owner, when it says owner, it is actually username. But in HANA, for every user you create, does it create a schema also? That's the concept. So it will have a schema. It will also have a user and a user also with the same name. Yeah. If I go to HANA database, security, users, I should see SAP ABAP 1. If you just straight away create schema, if you create user, it will have a schema also with the same name, but it will also have user also there. Now look at this. I have a schema called SAP ABAP 1 is my user also. Here a point when you have BW made to sit on HANA and you have owner, and every operation you're doing in BW, it has to do something in HANA. All those is handled by this user, SAP ABAP 1. Because when I try doing something in BW, if I get issues like saying no authorizations available to create this dictionary in HANA, who doesn't have authorizations? Not the user who have logged into BW. To BW, I can log into any user. But all the communication between BW and HANA happens using this person as the owner. So this person should have the relevant authorizations to communicate with the HANA database. Because initially we used to have a lot of problems, and it is all relevant to security or authorizations, majority of the issues. So we are trying to grant authorizations to this user, and we could solve a lot of issues. Ultimately, BW user to login. BW నుంచి HANA communication మాత్రం ఈ user తోనే జరుగుతుంది. Okay, done. So I think having that in mind, I think should help you. Whenever you get some issues of doesn't have authorizations to get all this stuff, this person should have those authorizations, not the user who logged into BW or not the system user what you log in HANA. This user should have that authorizations. Okay. So this is pretty much common. You'll have what RS1 and the Mamula. Yeah. So what they've done is with the BW powered by HANA. So once you have HANA as a backend, we're going to use it for both improving the performance of the system as well as query performance also. We've been using BW accelerator to improve query performance, right? But now if you look at having HANA as a backend, it does power the entire application as it is. Not only reporting or not only loading. The entire application performance itself is handled by HANA when HANA comes as a backend. So when you say BW powered by HANA, the major purpose of it is to improve the performance of the application as it is as a whole. Not loading or not reporting, entire system performance is handled by HANA because it takes in the complete pressure. HANA takes in the complete pressure of BW and gives you high performance of the BW system. That's the major focus. BW Accelerator was majorly focused on query performance only, but this focuses on entire system. Every operation of the system which is done in BW will be handled by HANA systems. There are some restrictions till BW 7.4 SP8, but from SP8, system takes in everything, reporting everything it takes in. Okay. So now with this, while installing, they would specify a schema name. With the same name, it will also create user name also. అట్లా మొత్తం ఆ డిక్షనరీ దాని మీద డిపాజిట్ అవుతుంది. You'll also have something like you'll have a T code called DBA cockpit. Okay, if you go to this T code, that is where you'll have the connection to the primary database. And BW is like a front end application, and you'll have back end database. The main connection ఆడ ఉంటుంది అన్నమాట. కొత్త సిస్టమ్ అంటే చూడొచ్చు వాడు ఎందుకు ఏ యూజర్తో కనెక్షన్ ఫామ్ అయింది. నో వాయిస్. హలో 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 I think it's fine. Okay. Yeah. Let it open. But in the DBA cockpit, you can see the primary database connection, or you can use a T code DBCON. DBCO, not even con. If you go here, you can see this database configuration about it is connected to this is a system ID. It is connected to what? HANA database. This is the host, and what is the user here? Yes, you can see this connection between primary database connection. Or even if you want to see all the database connections, you can go to DBCO. Yeah. You will get to see all the connections like this. Will be something many are there. DBCO, okay, DB connections. Okay. So what happens now with HANA coming in as a backend? Some of the existing concepts get changed, it has been enhanced, and some of the concepts has been removed and delta inputs. Okay, so we are focusing on those concepts. What is what has been changed, what is coming newly, and what has been removed out. Okay. So as part of this, we're going to touch pretty much of this HANA optimized info cube. HANA optimized DSO reconvert means actually when once HANA has come in as backend, SAP started with HANA optimized DSOs, but after some days they say it's no more required. So if there are some clients who have already converted to HANA optimized DSO, they have to reconvert it back to standard DSO. And as of now, you'll not be able to convert anything to HANA optimized DSO. Not no more supported. Yeah? There are some limitations. We'll see. First, I'll show you normal. Then we have this topic on database migration of HANA. A prerequisite change. We'll get into details. Then we'll focus on consuming HANA models in BW. Let's say we have BW, we have HANA in the backend. Let's say you have leveraged the backend HANA modeling and created your analytical views or attribute views or calculation views. How can I consume them in BW? That's fine. Next, how do we import BW objects into HANA? So let's say in BW we have created cubes or DSOs or master data, whatever it is. How do I bring them to HANA? Then how do I mix them with HANA modeling? For example, I have an attribute view in HANA. and I have a DSO, which holds a transaction data. Now I would like to import this DSO as an analytical view into HANA, then combine this with the attribute view which is already there in HANA, then build a calculation. So in this case, do I need to bring in the BW objects into HANA first? So that's where more of mixed approach, like you're consuming HANA models into BW and BW models into HANA. So when it comes to BW Power, he does not treat attribute view analytical as a separate provider. He treats it as one type of provider. Like how do we have cube or DSO or multi-provider info set, composite provider. Analytical view calculation is also like another provider. He mixes up so much that it's well integrated. ఎంత ఇంటిగ్రేటెడ్ అంటే అనలిటికల్ వ్యూ క్యాలిక్యులేషన్ కూడా క్యూబ్ లాగా ట్రీట్ చేస్తాం అంత లెవెల్లోకి వెళ్ళిపోతుంది. Then we have some this is nothing to do with HANA, but with BW 7. From 7.3 we started giving some concepts of ODP, source system connections through SLT, ACC, HANA views, what we'll see that. But major point focus is, see, చాలా మంది when they start speaking about, they say real time data అంటారు కదా. అంటే HANA as it is not real time. When HANA is accompanied with SLT, it starts giving you real time. So my point is, SLT can also be integrated to BW. Then HANA BW is also real time. అంతే కదా, నువ్వు HANA తగిలితే నేను BW కూడా తగిలి, BW real time. Yes or no? So that's where I was trying to focus on ODB, where we can also integrate SLT to BW and get real-time data also. Okay. And major focus on that is nothing to do with HANA, but major focus here is building up lean data flows. Now tell me what we're doing. We're running info package, it brings into data source, from there to DTP to target. Okay. So now what I'm saying is, I will not use info package. I do not leverage PSA. I'll straight away run the DTP, which will extract data from source and load it from the target. So PSA is you're loading to PSA, then again deleting, now it's all gone. They call this as lean data flow. Straight away DTP will be leveraged to load from source and load it to target. And delta will be handled in the source with the DTP requested. Any problem? They call it as lean data flow. Any issues? Similarly, you don't get saying PSA is used for error handling, we cannot use it. Yeah. Any doubt with that? Can I use error stack? Yes sir. Then next we have another concept called advanced DSO. This is major. This is the major enhancement. New topic coming in, advanced DSO. Now what it does is, what are the DSO we've been referring to now, standard DSO or whatever it is, we start calling it as classic DSO, classic one, the old one, and the new one is referred as advanced DSO. So cube is additive, ODS is override, modules. Advanced DSO is like one solution for every concept we have. You can create advanced DSO which acts like cube, which is similar to cube. You can create advanced DSO similar to SAT DSO, advanced DSO similar to write out DSO, advanced DSO, any combination you can create. What plan he says, I've given lot different type of objects like cube, standard DSO, and write out ways and each scenario. And why is given so many objects? Each object has got different functionality and different set of properties. But what he wanted to have one object. He didn't want to confuse everything, so you'll have only one object. He's given checkboxes. Depending on the checkbox what to select, the behavior will change. Sorry, DSO lag call kada. Advanced DSO or checkbox you belte DSO, normal DSO. Cube lag call kada. Advanced DSO more checkbox you belte cube అయిపోతుంది. Advanced DSO 4 checkbox you belte write out ways అయిపోతుంది. Okay solution, okay updating ఏ దానికన్నా అదే అన్నట్టు అది. Okay, అన్ని ఇదే గోయింగ్ ఫర్ అప్పుడు స్టార్ట్ చేశాను. క్యూబ్ లెస్ చేస్తాం. What a simple formula. If there is a cube with less than 120 characteristics, replace with advanced DSO. More than 120 characteristics, standard DSO. Because your advanced DSO can only hold maximum 120 fields as primary, not more than that. So when you look at a cube, all CAT6 must be referred as primary key. And almost all the CAT6 in the queue must be referred as key. So if it is within less than 120 limit, I can convert that as standard DSO where all those can be referred as primary key field flagger. But if it goes beyond 120, I cannot handle that. So I'll go with standard DSO, identify the granularity, and then put document number or item number into key fields and then handle it. That was strategy. But then tana rare and 120 pine on the CAT6 cube and put the rare usually. So our formula 120 get takunte replace Q with advanced DSO, 120 get takunte standard DSO. Q will left another. Because the performance on now with HANA, performance on DSO, performance on Q is all same. No difference. Then open ODS view. This is like అంటే ఇంకో పాయింట్ ఏమంటారు అడ్వాన్స్ డిఎస్ఓలో ఫీల్డ్ బేస్డ్ మోడలింగ్. అంటే వాట్ ఏమంటారంటే సపోజ్ ఇన్ ద సోర్స్ ఐ హ్యావ్ 120 fields in a table. I got to load the table into BWS. You end up creating 120 infobits. Are you taking a lot of time? Why you want to do that? Leverage the same field definition metadata and then create your DSO. Infobit లో అవసరం లేదు. You can use a field based model. ఆ ఫీల్డ్స్ లో టేబుల్ లో ఫీల్డ్స్ మెటాడేటా వాడుకుని ఫీల్డ్స్ పెట్టుకుని చేసి అది మెయిన్ అడ్వాన్స్ చేసి ఇంకా ఫీల్డ్స్ ఇన్ఫోబిల్ కలపచ్చు. కొన్ని ఫీల్డ్స్ కొన్ని ఇన్ఫోబిల్ కూడా కలిపేస్తాం. నెక్స్ట్ ఓపెన్ ఓడిఎస్ వ్యూ. దిస్ అగైన్ కంప్లీట్ ఫీల్డ్ బేస్డ్ మోడలింగ్ అండ్ వర్చువల్ ఆబ్జెక్ట్. Now we have like remote view. Same way open ODS view is also virtual object, but this is field based. And what are the fields we have in the source? We going to leverage the same fields definitions, metadata, and then create this object, virtual object. Then we have something called composite provider. Now we have multi-provider and InfoSec. This would be a replacement for both of them. Instead of using multi-provider and okay, we have multi-provider and InfoSec. Replacement of both would be composite provider. That's the concept, because composite provider can handle join as well as union also. Okay, boss? In out of context. He's saying modeling in BO and HANA is both same. If you do modeling in BO, you're playing that logic in applications layer. If you're doing modeling in HANA, you're pushing that logic into database layer, which is in memory. So you would see high performance when you do modeling in HANA than BO. So going forward, these three will be the game. Advanced DSO, open ODS view, composition. The next they'll be still be using more of classic DSO, standard DSO. Okay. In that one concept, you want to do reporting on some. You have some data in Excel systems. You would like to consume in BW do reporting. And there is BW. So you want to consume them virtually, open ODS view. You want to store data physically, standard DSO or advanced DSO. Preferable advanced DSO. If not, then standard DSO. Data virtualizations, open ODS view. Data physical persistency, standard DSO or advanced DSO, and then composite provider. Cube ఉంటుంది, you can still leverage, but the point is either you do reporting on Cube or DSO with HANA as a backend, you get the same performance. So then why should I manipulate Cube which holds so many tables and then joins? I can just straight away go with DSO, simplified modeling. Yeah? Next, we have something HANA transformations using ABAP managed database procedures. Like in transformations, we can implement SQL script also. So the logic is, if you want to get the high performance, as much as possible, you got to start pushing the load of BW to HANA database. We first thought of doing what? Pushing code to the database, right? Same way. If you write your logic in ABAP, HANA would not really understand that. So you can implement your transformations with SQL script so that you can push that logic to HANA database and execute it in high performance. So we can push it through something called ABAP managed database procedures or concept through which you can interface ABAP and scripting. And then SAP HANA NLS, nearline storage. This is like a second database or archiving database. See what they do, they categorize the data into three things: hot, warm, and cold. Cold is like never used at all. Warm is like we rarely use. Hot is we frequently use. So basically they categorize. Say for example, data of DSO and standard DSO and cube is hot. We really use it for reporting. For write-up means which is used for staging or other DSOs which we are not really using it for reporting, that is like warm for me. PSC is like cold. I don't really need that at all. ఈ warm and cold, what the cold ఏంటంటే అసలు అవసరం లేదను they start moving this into secondary database. Whenever you have ANA, you will have NLS, nearline secondary database, Sybase IQ ఏదో ఒకటి ఉంటుంది. Preferably they go with Sybase IQ because Sybase IQ is also holds column stored database. Yeah? So when you PSA tables, write up based ఇవన్నీ దాంట్లో పెట్టేస్తాం. చెక్ బాక్స్ ఉంటుంది పెడితే create extended storage అంటే all this will get stored into that automatically. So we can because it is in memory database, we have to use this memory intelligently, not for all this stuff. Then BW workspaces come. This is like end user flexibility where they can create their own whatever, like your own modeling. You have a cube, they want some more field. మనం ఏమంటే 3 months time తీసుకుంటాం. వాడు immediately we can change himself. His own workspace. He can create his own local providers, local reporting he can do. And then semantic part, we know this like splitting into multiple objects based on some partition fields. Hybrid provider, when you want to integrate cube with virtual cube or cube with RDA, DSO, we go with hybrid provider. Then planning kit, there's nothing much, but only because the concept of IP, if you use integrated planning, you start now if you install this planning kit, all the planning functions start getting executed as a stored procedures in HANA database. If you install this planning kit, all your planning functions internally start getting executed as stored procedures. And with that, you see high performance with IP. Not the because the performance of IP is a lot better with HANA than BPC. So you see some customers implementing planning with IP rather than BPC and they're saying they're getting good performance when they use IP because it is directly pushing the logic into HANA database. So only planning instead of going with BPC, they can start to leverage IP అన్నట్టు అంటున్నారు. ఓన్లీ కన్సల్టేషన్ BPC, ప్లానింగ్ అంతా IP అన్నట్టు అంటున్నారు. అందుకే మళ్ళీ కొద్దిగా ఐపీకి అడుగుతాను జనాలు. We have to install it and then enable some settings. Then we deliver. If it is inventory key, we'll have some marker updates, all those, right? So with BW Pod by now, how do we handle inventory management? We see this. Then we have something called SAP analysis process, something like APD. Analysis process design, like here, same like this, but you want to implement scripting into it. Then you go with HANA analysis process. Then LSA plus now layered and scalable architecture, and with HANA coming in, we simplify it more. For example, మనకు మామూలు బిల్డ్ అంటే ఇట్లా అలవాటు కదా, లోడ్ స్టేజింగ్ లేయర్, ట్రాన్స్మిషన్ లేయర్, రిపోర్ట్ అన్న పంచాయతీలు ఒకటే లేయరే రిపోర్టింగ్. ఎందుకంటే మనం ఎంత తక్కువ అయితే అంత డేటాబేస్ యూజ్ చేయాలి, అది మన ఫోకస్. ఎందుకంటే అంత పర్పస్ బాగా ఇస్తుంది, అది మనం ఎక్కువ ప్రెషర్ పెట్టుకుంటున్నాం అట్లా వాడాలి. అంటే అప్పుడు ఏం చేస్తారంటే వాట్ ఎవర్ డేటా యూర్ లోడింగ్, you're trying to load DS with 120 fields and you're creating aggregated queue with only 50, 60, what you want. Don't need to do that. It says you maintain data at any detail, I will handle the performance. That's one concept. Okay, so if you're using the data mart just for aggregating your data, please remove them and start having the reports on DSP. Okay. Then database migration on HANA. Now let's see, if you want to install new HANA database, you will install HANA database, then you install BW software on top of it. That's straightforward. But you got existing BW running on a different database like DB2 or SQL Server or Oracle, whatever it is, and I would like to migrate the database. Migrated database మారిపోదు, ఇంట్లో ఉన్న డేటా దాంట్లోకి పోతుంది అంతే. డేటాబేస్ కన్వర్ట్ కాదన్నా, DW SQL Server database. Now I would like to migrate the database to HANA. You install new HANA database, you run some software where you say migrate the data from this database to this database. Okay, ఈ డేటాబేస్ లో డేటా అంతా దానిలో కూర్చుంటారు. ఇది కన్వర్ట్ కాదు. కూర్చుని now then the BW will start connecting to what? HANA database. And they have given some software tools to do that. If there is some problem, immediate fallback can be done. One link weak దానికి పెట్టి ఇక్కడున్న డేటా దానికి తప్పి లింక్ పెట్టినావు కదా, ఒక తేడా వస్తుంది, ఆ లింక్ నేను పెడితే అయిపోయింది, మళ్ళీ వర్క్ అయినట్టు కదా. అర్థమైందా? ఈ లింక్ వీక్ దానికి పెట్టినావు, డేటా ఇక్కడ అటు పోయింది కదా. సో యూ హ్యావ్ ఆప్షన్ ఆఫ్ ఇమిడియట్ ఫాల్ బ్యాక్ ఆల్సో. దట్స్ పాయింట్. తేడా వస్తే మళ్ళీ కొద్దిగా పాతేవాడు అని కూడా అనొచ్చు. సో అది ఎలా చేయాలి, ఏమేమి ఆప్షన్స్, ఎలా ఆప్షన్ ఎట్లా చేయొచ్చు, ఎట్లా చేయొచ్చు, ఏది బెస్ట్ మెథడ్ ఎట్లా అనేది ఫీల్ చేసి ప్రీ స్టెప్స్ ఏంది, పోస్ట్ ఏంది, ఎట్లా అవుతుంది. I will provide, for example, RDA DSO ఉంది. You've been loading through RDA DTP and RDA info package. Active request yellow లో ఉంది. From the DSO, I would like to load into another queue. Then what do? Then we go with hybrid provider. That's ఒక option. ఇంకో option, let's say I've got virtual remote, I've got SAP remote queue. I'm consuming the table remotely from a different source. ఇప్పుడు నాకేంది ప్రతిసారి రిమోట్ వద్దు. నాకు ఎట్లా కావాలంటే నిన్న డేటా వరకు లోడింగ్ చేస్తాను, ఈ రోజు డేటా మాత్రం రిమోట్ కావాలి. అర్థమైందండి? అప్పుడు ఏం చేస్తానంటే అలా అనదర్ క్యూబ్, బేస్ క్యూబ్, వేర్ ఐల్ బి డూయింగ్ సేమ్ డేటా సోర్స్ ఐల్ బి యూజ్ ఫర్ లోడింగ్, సేమ్ డేటా సోర్స్ ఐల్ బి యూజ్ ఫర్ వర్చువల్ కావచ్చు. ఏదైతే లోడ్ అయిందో లోడింగ్ క్యూబ్ నుంచి వస్తుంది, ఏదైతే లోడ్ కాలేదో అది వర్చువల్ గా తీసుకొస్తుంది. ఇఫ్ యూ ఎనేబుల్ దోస్ కైండ్ ఆఫ్ ఆప్షన్స్ దెన్ యూ గో విత్ హైబ్రిడ్ ప్రొవైడర్. ఓకే. So that is what we're trying to focus on. Now next first topic, unoptimized info cubes. So unoptimized info cube is not a new concept. It's an enhancement to the existing topic, info cube. Info cube అని ఉంది. ఆ info cube కొద్దిగా enhancement, unoptimized info cube. Okay? In a normal BW with non-HANA database, you know about schema, right? Fact table, F table, E table, connected to dimension table, SI to master, you know this. So now what they do is this schema has been, what I want to do, if it is non-HANA database, I wanted to have so much of complex schema to implement performance, but now I don't need so much of complex schema, I can still simplify it. We have it as unoptimized schema now. We have fact table straight away connected to SID tables and SID table connected to master data. No more dimension tables. Okay, exception. We'll have one dimension called data packet dimension. We'll have only one dimension called data packet dimension. And straight away fact table will start connecting to what? SID, like line item dimension, straight away they start connecting to SID tables, and SID table will start connecting to master data. And there is no primary key in your fact table. And that fact table is a column store table, and no primary key into the table. That's why it is allowing you to have n number of SID tables. It says maximum how many characteristics, and maximum restriction will still hold good. So while creating cube, you see create dimension at all. Yes or no? I know, but internally it is not creating dimension table, but the number of characteristics assigned to that each folder still holds good as 248. You can create 13 into 248, restriction in that level. When you select the dimensions folder, right click, create new dimension, it is going to create a new dimension for you. Because in the dimension table you create the screen. You still create a folder, you put this is what it says is, I know even though there is no dimensions getting created in the backend, use that as organizing. Customers know the products and know that just like organizing, so that when you go to BIX reporting, instead of searching a very big list, I can straight away logically group. If it is logically grouped, I can search the respective block and drag things into the reporting. But the number of key figures 233, number of characteristics 248 over one dimension still holds good. The restriction is still there. Okay. And we'll have only one dimensional table called data packet. Okay, Nana? That is unoptimized. Okay, Nana? Fine. And no more E table, only one table, F table. No more E table, only F table, and connected to all SID tables, and only one dimension table data packet connected to dimension table, data packet dimension. What is it? Yeah. So factor will start showing you SIDs which is linking to SID table directly. Yeah. So we'll just create one cube. I want to create one info area. Okay, I have this area and again cube will some cube. I'm not creating in fabrics, I'm going to create copy from that. So I'm going to copy the structure. See, standard cube. I never specified optimized, by default it is unoptimized. With the HANA backend, what are the cube you create newly, by default it will be unoptimized. Okay. But if you are migrated, you don't see the cubes as unoptimized, you will see it as normal cube. Where different database to other database. So I've got this cube. See, I can assign n number of things, n number of characteristics also. Still limit of 248. Okay. So I've used so many characteristics and I've got some keys here. Okay, boss? And I'm going to activate this key. So by default, the new cube what it did, it is an optimized cube. So there are certain aspects what you would observe. If you go to extras menu, information log status, if you see dictionary DB status, you will see the tables. What do we have? F cube 05, what is it? Fact table. D cube name P, what is it? Data packet dimension. That's only two tables. And SIDs would have been connected to my fact table directly. Okay. We know about opening these tables in SC11, yeah? Can I see that in here also? Database login but now since we can start logging into HANA database and see those tables also. Now tables let me filter for cube 05. So I still see the fact table and SC11 anyway. Now first I would like to show you this fact table. Symbol is column store table with partition. Put the columns into column store, gap put them partitions. Right click and show open definition. See what you see in it. This is a fact table name, schema, column store table. And you see all these are the columns in my fact table. You see what is this? Key under this is what we used to have previously. We have a key still here. What is it doing? Data packet dimension. This is the key which is connected to my data packet dimension. And all these are what? I had almost 19 characteristics. For all the 19, it is referring to the SID of those characteristics. Is it like line items? I have so straight away SID tables are getting connected to my fact table first. And no primary key. Look at this. Nothing is defined as primary. Okay. And straight away key figures are in the fact table. Look at this. Okay, done. So You're okay with this fact table structure? The next point to be focused is, by default, it's a column store table, and by default, you see you'll have 4 partitions created onto your fact table. You get what is this? It does use round robin mechanism and create the partitions, 4 partitions. Partition 1, 2, 3, and 4. Okay, boss? 1 epudu, 2 epudu, 3 epudu, 4 epudu అని పాయింట్. ఓకే, 4 తీసుకుంటాం. Let's say you have a cube. Cube is what now? Fact table, right? Now you run the DTP to load in. మామూలుగా కదా info by DTP కొడతాం, cube లో load అవుతుంది. When the DTP is, when you trigger the DTP, all the data is loaded into 4th partition first. 4th means 4th partition is for all uncompressed requests. 4th partition will have all uncompressed requests, and once the request is compressed, it will start going into partition number 1. Okay, Nana? When you load data into the cube, it gets into partition number 4. Once the request is compressed, it gets into partition number 1. Okay, Nana? Then what? Always fixed 4 ఉంటాయి. So now, first when you trigger the data into the cube, all uncompressed requests will be in 4, and compressed requests will be in 1. Other point. Next, what about 2 and 3? And 2 and 3 will be leveraged only for non-cumulative cubes. When you implementing inventory management, partition number 2 and 3 will be leveraged. Partition number 2 will hold initial stock, and partition number 3 will hold all the movements. See, any type of cube we create, it will be always creating 4, but here వాడుకుంటుందనే depending on the type of cube. ప్రతిసారి 4 ఉంటుంది, వాడుకునేదానికి సినారో బట్టి మారుతుంది అంతే. If it is inventory cube, it will be using 2 and 3. If it is non-cumulative cube, it will be using 1 and 4. But always it creates 4 partitions. Okay, Nana? So, got this point? 4 partitions we can see, but as of now there is nothing. See, record count says what? 0 in all, because we have not done any loading it. Another point. అవును, వాడకపోతే మెమరీ అలొకేట్ కాదు, ప్రాబ్లం ఏముంది? వాడకొస్తే మెమరీ పోతుంటుంది కదా, కొద్ది బేసిక్ ఉంటుంది. ఇటువంటి కెన్ డ్రాప్ ది పార్టీస్. జనరల్లీ 1 and 4 ఆర్ యూజ్డ్. అంతే, చెప్పండి దానికోసం. మళ్ళీ డెల్టా ఇట్స్ కాలమ్ స్టోర్ అంటే కాలమ్ స్టోర్ టేబుల్ షుడ్ హావ్ వాట్? డెల్టా మర్జింగ్ షుడ్ బి దేర్. దాని పాయింట్ ఐఎమ్ గోయింగ్ టు కమ్ టు. 1 second. క్యూబ్ లో కంప్రెస్ ఉంటుంది. క్యూబ్ కంప్రెస్, రైట్ క్లిక్, కంప్రెస్, రిక్వెస్ట్. నేను చెప్పినాను అట్లా. ఈ టేబుల్ ఏం చెప్పినా కంప్రెస్ లేదని చెప్పలేదు కదప్ప. ఇప్పుడు ఎట్లా యాక్చువల్ లాజిక్ ఈ టేబుల్ ఎత్తేసి వాడు ఏం చేసినాడంటే, 4th partition is like F table, partition number 1 is like F table. ఆర్ది లాజిక్. 2 టేబుల్ పెట్టే బదులు 4th partition will be like F table. Partition number 1 is like E. అంటే before compression it will be in 4. After compression it will aggregate the data and push into partition number 1. అది 1 కాదు. కొత్త టేబుల్ బదులు దాంట్లో ఇంకో బ్లాక్ క్రియేట్ చేసి పెట్టాడు. ఎందుకంటే డేటా టేబుల్ ఎంత డీటెయిల్ ఉన్నా నేను చూసుకుంటా అనే కాన్సెప్ట్ కాబట్టి స్ప్లిట్ లో ఒకటే టేబుల్ బ్లాక్ చేసి. If you see, you can see pretty much the properties of the table. What type of table is this? Column store table. What is this? Auto merge on. What is it says? auto merge కాదు. So what merge is smart merge. Okay, boss? Yeah. And merging is, we'll see that in the DTP you'll start seeing a property called trigger database merger ఉంటున్నారు, which will basically trigger the merging, which is nothing but smart merge. So auto merge is off అంటే నెక్స్ట్ auto merge ఆఫ్ ఉంది, నువ్వు ట్రిగ్గర్ చేస్తున్నావు, ట్రిగ్గర్ చేసినప్పుడు రన్ అవుతుందంటే స్మార్ట్ merge. I can also see, look at this, it says what is it? Preloaded, but no. At a preload flag set leదంటే ఏంది, when you switch on the server, it will not get loaded to main memory at all. Only when you run the query first time, if it is referring to this cube, then the cube starts getting loaded to main memory. Is partially preloaded మామూలు, unload priority ఎంత ఉంది, బస్ 5. సో 0 అంటే ఎప్పుడు ర్యామ్ లో వచ్చినది, ఐఎస్ అంటే తేలిపోయింది, 5 ఉంది, దాన్ని బట్టి మెమరీ అలొకేషన్స్ బట్టి టీఎస్ అంటుంది దీని క్యూబ్. So basically you can observe all these properties here. This is a fact table. Same way you'll have your what? Data packet dimension. Okay. You have dimension ID, yeah, and then request ID, record type, change run ID. Pretty much same of like this. You have request ID, considering record type, yeah. This will play a very, very important role. We'll see. But this is going to be data packet dimension. This is only one dimension table which will have. Okay. Because what I want to this is how the structural schema has been changed. Now, what do you think is a benefit? Logical knowledge. ఇలా schema మారడం వల్ల benefit ఏముంటుంది అనుకున్నాం? What do you think would be the benefit? Let's discuss on loading. Let's say you have this type of schema and you're loading this. What is the benefit you think? Figure out if it is old cube, if I'm loading, and then if it is a new type of cube, if I'm loading, what could be the difference? He says, if I'm loading data into the unoptimized cube, I don't have to generate any dimension IDs, so it does improve my loading performance. Accepted. If it is normal cube, I'll have, every time I load, I need to generate my dimension ID, so does it take a lot of time? Logical knowledge is saying yes, still, yeah. మనది క్యూబ్, పాత్ క్యూబ్ కి కొత్త క్యూబ్, అది మన ఫోకస్. Even change performance changes to this cube would be easy, now in the older cube, can you delete a characteristic out? If even there is data in the cube, I could add a new characteristic, but could you delete something else which is already there? No. But here, removing, adding, replacing would become very, very simple because there is no dimension tables. Just adding, removing it further. Because very simplified remodeling is possible, and the simplified remodeling, simplified modeling also. Unna model changes కాబట్టి కొత్త మోడల్ క్రియేట్ చేయాలనుకుంటే no more analysis. ఇది రెండు should have put them into same dimension, should have put the different dimension in the left and right. అదొక 5 ఇదొక 5 వేసుకుని పోతాం. While creating cube, there is no more analysis like say 1 to 1, 1 to many, 1 ఇల్లే 20 ఉన్నాయా, 5 4 వేసుకోవడం అట్లా వేసుకుని తప్పేం లేదు. బికాస్ అల్టిమేట్లీ నువ్వు ఏ డైమెన్షన్ ఎక్కడ వేసినా కూడా అన్ని ఎస్ఐడి వచ్చి కూర్చుంటాయి కదా. నో మోర్ అనాలిసిస్ టు బి డన్. స్ట్రైట్ అవే జస్ట్ అసైన్ సమ్ క్యారెక్టరిస్టిక్స్ టు ఈచ్ ఆఫ్ ద డైమెన్షన్స్ అండ్ నో మోర్ కార్డినల్ నథింగ్. బికాస్ డైమెన్షన్ టేబుల్ లేదు ఇంకా దాని కార్డినల్ యాడ్ లేదు. ఓకే బస్. అండ్ విల్ ఇట్ ఇంప్రూవ్ మై క్వెరీ పర్ఫార్మెన్స్ ఆల్సో. వై? Directly your fact table starts joining to your SI tables. So no, you're eliminating lots of joins in middle from fact to dimension. వాళ్ళు అదే చెప్తారు. So benefits of unoptimized cube: simplified modeling, simplified remodeling, faster loading. నువ్వే అది చెప్పినావు, రైట్. ఇంకోటి ఏమంటాడంటే ఇది ఓకే కదా బస్. Still there is dimension called what? Data packet dimension. ఇవిడేమంటారంటే యాక్చువల్గా వాడు డేటా ప్యాకెట్ డైమెన్షన్ ఎందుకు పెట్టినాను అనే వన్ ఫోకస్ అన్ని తీసిన అది ఎందుకు తీయలేదంటే రిక్వెస్ట్ వైజ్ డిలీషన్ కోసం. ఇంకోటి ఏమంటాడంటే ఇప్పుడు నువ్వు డైమెన్షన్ జనరేషన్ ఎక్కువసేపు పట్టాను. ఫర్ ఎగ్జాంపుల్ నేను ఐఎమ్ లోడింగ్ 1 million రికార్డ్స్. అండ్ ఒక్కొక్క రికార్డ్ కి డిఫరెంట్ క్యారెక్టరిస్టిక్ కాంబినేషన్ ఉంది అనుకున్నాం. సో వీల్ జనరేట్ 1 million డైమెన్షన్ ఐడీస్. ఓకేనా? I'm loading 1 million records, different characteristic combination at a time. How many dimension IDs will it generate for data packet dimension? అర్థమైందా? 1 million రికార్డ్స్ లోడ్ చేయమ్మా. వేరే క్యారెక్టరిస్టిక్ కాంబినేషన్ ఉన్నప్పుడు 1 million డైమెన్షన్ ఐడీస్ జనరేట్ చేయాల్సింది ఆ డైమెన్షన్ ఐడి. మరి డేటా ప్యాకెట్ డైమెన్షన్ లో ఎన్ని డైమెన్షన్ ఐడీస్ జనరేట్ అవుతుంది? ఒకటే. కాబట్టి స్పేస్ పెద్ద కథ ఏం కాదు. జనరేషన్ కూడా ఒకే నంబర్ జనరేట్ అయ్యేది. సో ఐ డోంట్ హావ్ టు వరీ అబౌట్ పర్ఫార్మెన్స్. ఇఫ్ ఐ మెయింటైన్ దట్, I get a benefit of deletion by request. If I don't maintain that, how would I know which record belongs to which request first? డేటా ప్యాకెట్ పెట్టుకోలేదు అనుకున్నా క్యూబ్ లో. ఏ రికార్డ్ ఏ రిక్వెస్ట్ ద్వారా వచ్చిందో నేను కనుక్కోలేను కదా. సో ఐ కాంట్ డూ డిలీషన్ బై రిక్వెస్ట్. దానికోసం పెట్టాను. ఇంకోటి డేటా ప్యాకెట్ పెట్టడం వల్ల నాకేం పెద్ద సైజింగ్ ప్రాబ్లం లేదు, జనరేషన్ కూడా టైం ఎక్కువ. ఎందుకంటే there will be multiple records. When you load 1 million records, it does generate only one request ID, only one dimension ID. If you look at other characteristics like customer or product, if I'm loading 1 million with different combinations, it does generate 1 million dimension IDs. Then it takes a lot of time. But if I'm loading 1 million records at a time with single request ID, it has generate dimension ID only one dimension ID has to be generated, so it doesn't take much time. So you don't have to worry about generating dimension IDs for data packet dimension. It generate only once for every request. It does give you benefit of request based deletion. That's why we still hold data packet dimension to achieve. You're saying after compression you can't have this. Once it is compressed, you will not have requested information. You can't delete. I accept it. You should keep doing compression. What I want to say, 2 billion rows. I'll show you. He says, actually no, the concept is, no, should I do compression? If you're not compressing, it is in fourth partition. If you're compressing, it is going to first partition. Now, should I do compression? Even if I don't do compression, it is still in F table. Even if I do compression, it is still in F table. Now, you're saying HANA can handle the performance even if the data is in detail. Then why should I do compression? And that's the question, right? You're saying data could be any detail. HANA will handle the performance. And whether you partition it or not, it's still in the same table. Then why should I do compression? So the concept here is, why should I do partitioning is to improve the performance of delta merging process. We still need to do compression to improve the performance of delta merge process, because let's say you're not doing compression. Will all data be into fourth block? Let's say now fourth block is 1 million records. You're doing merging. Merge will get performed on what? Merge is performed on every partition by partition. And it does only perform the delta merge on the partition which has got some new data gets in. Okay, now I've got 100 million records in fourth block. You load one record. You perform merge. Again, it checks every record again. Yes or no? Suppose if you put a partition saying all 100 million what I had is already compressed, it is in first partition 1. Now you load one record goes into what? Fourth partition. Now since the new data changes have been done only for what? Partition number 4, merging will trigger only 4. You remember? During delta merging I told you it is done, every partition will have main table, delta table, main table, delta table. So delta merging is specific to each partition block. So if I keep compressing it, all the compressed data will go to first partition. The new data what comes in will be in fourth partition. So delta merging should be done only for that particular request alone. So it does improve the performance of delta merging. We are not compressing to improve performance of query, or we are not improving performance of database performance. We are focusing on delta merge performance. Okay, boss. Now you see, how do we create HANA optimized new one, and what are the new cube you create? It is by default HANA optimized. Okay, boss. But let's say I already had a BW system running on a SQL server. I have migrated this database from SQL server to HANA database. From BW SQL, I've migrated to HANA bus. So all the cubes which are already there will not get migrated as HANA bus. Migration transport. If I transport my cube from BW is equal to BW HANA, that gets migrated as unoptimized automatically. Transport ద్వారా ఇచ్చే. I'm not speaking about transfer, I'm speaking about migrating. And ఉన్న database exported and imported to HANA database. In that case, existing cubes are still like that, normal standard cubes. Then once the BW is migrated, do I need to convert them to unoptimized cubes? Yes or no? That's the focus. How do we convert this? Now you can either use this T code RSMIG or HANA DB T code for migrating cubes from normal standard cubes to unoptimized cubes, or you can either use this program RSDRI underscore convert cube to in memory bus. Yeah? If I I'll try to get it done before we complete the course. Somewhere I'll get this. Okay. See that. So this is a T code where you can, let's say you want to migrate some cube. You just specify the cube name here and execute it. Okay. If you want to migrate multiple cubes at a time, then click on this arrow mark and start specifying any selection you want and then execute. Then what they do, they try to go with application by application, SD1 also or EMM also, set by set, run noticeable. Now when I do this, now considerations. Now will it disturb my data? All those points. So you don't have to delete any data to do this. Even with the data, it does do the conversion. You don't have to worry about it. Okay. Even during conversion, reporting is also possible. Even during conversion process, reporting also can be done. It does. Okay. But data loading cannot be. Data management is not allowed during migration, but reporting is still possible during migration. Except dimension, except data packet and deleted. So that's a convert just petition. Loading allowed. Reporting during migration, we can still do reporting, but not loading allowed. And one more thing, once the cube is migrated, it does not disturb transformations, does not disturb DTP, does not disturb your multi-provider, does not disturb your big storage. Nothing is disturbed. Just the cube gets migrated. As simple as it. And when it's migrated, the backend schema gets changed. You don't have to do anything. Okay, Nanda? No. And there's some points to be noted. And look at this. Now I can't show because there is no cube which is like that. But I'll get it done by 2 or 3 days. I'll get some cube like that and show you migrate. And once it is migrated, you just use this T code SLG1 for the log. If it is like say you've done the migrations, I want to see the log of it. I can see in SLG1. Like all application logs can be seen there, right? You can see even logs of migration also there. Okay. After the conversion, we just as a standard cube before. There's no need to change any load of DTP, load process, DTP, multiple, nothing needs to be changed. During a conversion, a lock is set, preventing all maintenance activity and load process. Only maintenance. During migration, you cannot change my cubes or you cannot do any loading, but reporting is still allowed. But querying on the cubes is however possible during migration also. And one second. And cubes with non-critical keywords can be converted. Even if it is non-critical, we can still convert them. Event cube will convert this. But if it is flow is 3.x, we would not do conversion because it's not a compulsory. Suppose cube compression. For example, you do triggering delta merge trigger chestamu. Delta merge trigger cheyalla vadda avani DTP lo untundi settings. Suppose your cube data flow is in 3.x, it does not have DTP, right? So how can they trigger delta merge? So what they do is you basically have to convert those 3.x flow to 7 flow, then migrate your cube to unoptimized. So 3.x flow, if you still have update rules, transfer rules, and old flow, migrate to 7 flow, then look at optimizing your queues. Hanan. And then we know about partition. Partition 1, 2, 3, and 4. You will have it. Only one factor still have the option to run compression. We can do still compression in the queue. Yes. HANA compression. No, we can still do compression. And the logic of compression is performed as a stored procedure in HANA. And the compression just say good performance faster. The logic of compression is not like ABAP program now. It's all with the stored procedure. Compression is required to speed up what? Merge, not for the querying process. But this becomes only relevant for large and very large cubes, where it is like 10 to 50 million records. Work problem. Anything beyond 50 million, then we should really look at having a problem for it. Okay. Inventory handling, you can still, if BW supports with BW powered by HANA, we can still have inventory handling also. We'll see that inventory. No more aggregates is required with BW powered by HANA, and no more DB indexing, no more DB statuses. Suppose if you have process chains which still have the delete index, create index, or those DB statistics, they would do nothing. So once it is, they can do that optimization of organizing those process chains by eliminating all those unnecessary processes. Only work out. Roll up ledu, initial fields undu, delete index, create index, then DB statistics is all ruled out. Indexes. Okay. And just put the restrictions. Non-connected queues with 3.x cannot get migrated directly. Okay. And queues in SPO, semantic partition object queues in because they don't. If I migrate SPO, it does not get migrated immediately. So you've got to migrate SPO as well as the cubes inside. You have to explicitly migrate them to unoptimized queues. Yeah. And number but selection list and info cubes in hybrid product can be migrated. Sorry, cannot be migrated. If it is in a hybrid product, I told you, hybrid product can include base cube as well as virtual cube. Those cubes cannot get migrated. Other restriction, and I can refer. This is next topic we will deal with how do we implement inventory management with the base cubes. So we'll stop it here. Tomorrow I'll just have this cube and do some loading. Then we'll see how to implement inventory management of this.